Hello and welcome to the next section in the unit. This section is going to deal with parts of similar triangles, specifically some theorems that are pretty similar to each other that deal with altitudes, angle bisectors, and medians of similar triangles. We're going to use kind of the same two triangles in our diagram throughout this lesson, and just to put it out there right now, the two triangles are similar, and will continue to be similar throughout this section of notes. First theorem we can talk about: if two triangles are similar, then the lengths of corresponding altitudes are proportional to the lengths of the corresponding sides. So whatever the scale factor is for the sides of the similar triangles, so shall the scale factor be for their altitudes. To draw this in pictures, I'm going to need to draw in the altitudes, which go from an angle to the side opposite, forming a perpendicular intersection. I'll label these points U and points P. And following this theorem, we can make the following claim. The length of RU divided by the corresponding length of MP, since they're both altitudes, would be the same as the length of RT over the length of its corresponding side. Or, put it another way, the length of RS over the length of its corresponding side. Or the length of ST over the length of its corresponding side. Take your pick, or take all of them if you want. They're all true. So it's basically like having a fourth side to the triangle that is also following the rules of proportion. All right, so now let's take out the word altitudes for the next theorem and replace it with the words angle bisectors. All the other stuff in the theorem is true. So it's really just a different way of drawing that fourth side. Let's draw in the angle bisectors. An angle bisector comes out of an angle and goes to its opposite side. To show that they are indeed bisected angles, I will draw in congruence marks. And I'll name the points on the opposite sides once again UP. And following the logic of this theorem, we once again get the same four ratios. The only thing that's changed here is that instead of RU being an altitude and MP being an altitude, they are now angle bisectors. So U and P are in a little bit different place, but the result doesn't change. All right, now we're going to take out the phrase angle bisectors and replace it with the word medians. A median, hopefully you remember, comes out of one of the angles, goes to the side across from it, and splits that side into two congruent parts. So our altitudes are, if we name the points on the opposite sides U and P again, our altitudes are now RU and MP. And as you might expect, we get the following four ratios, which are exactly the same as they were for the previous two theorems. The only thing that's changed is that U and P are in a little different place than they were because RU and MP are found a little different way. But they still represent like a fourth side for a triangle, and that follows the same scale factor that all the corresponding sides do. All right, moving on from that. We have a triangle angle bisector theorem, which states any angle bisector in any triangle will separate its opposite side into two segments that are proportional to the lengths of the other two sides. I'm going to give you a half a minute to process that. A picture, perhaps. There is an angle bisector for the lower left angle in this triangle. I'll verify it by putting in my congruence marks. I'm going to name some of the segments around the triangle now. We have side A, we have side Y and side Z, which are not necessarily congruent. Well, I and Z do not have to be congruent. this and this could well be different lengths. But what we can claim due to the triangle angle bisector theorem is that taking y and dividing it by z will give you the same result as taking a and dividing it by b. That's what they mean by segments that are proportional to the lengths of the other two sides. An example, perhaps. First thing, we got to fix a little typo I made. This ABC it's gonna be an easy typo to fix because ABC just needs to turn into ABQ. Unfortunately, it's really easy to make a C into a Q. There we go. So now we can mark our given information on the diagram to help us. So ABQ is this top angle. QBC is the angle right below it. AB, side AB is a length of 16, QC is a length of 5, AQ is a length of 4, and determine CB. That's the X marks the spot there. That's what we need to figure out. The fact that those two yellow congruence marks are in there tells me that side BQ is indeed an angle bisector. And since BQ is an angle bisector, we can apply the angle bisector theorem, which states that will relate to this side in an equal way that this side will relate to this side. As a result, we get a pretty nice proportion, which when you cross multiply, comes out to a nice round answer of 20 for x. X represents the side of length BC. That's what we're looking for, so we've answered the problem. We'll be answering many other problems like this in the very near future.